I'm Alex. I'm working as an AI engineer at King. King is a mobile game company. We made over 200 titles, and our most popular one is Candy Crush Saga, and we have approximately 270 million players per month. The problem we tried to solve with Google Cloud Platform was content balancing at scale. Every week, we have to create 15 new levels, and those levels they have to be enjoyable by everyone. So every time we release a new level, we wanted to provide fast feedback to our level designers so that they can make better content of a higher quality. So with human playtesters, when you have to wait for them to play the levels, you get your feedback in a week. The advantage of virtual playtesters, you can just create thousands of them. They will get the same feedback in a few minutes. You can use machine learning to create a machine learning model that plays like a human. To train our machine learning models, we chose machine learning engine from Google Cloud Platform. You can create containers for your games and for the virtual players, and then they can interact between each other. You can just scale up or down, depending on the load you have. At the end of the day, you only pay for a few computing hours. So having AI solutions like this allow us to play our content automatically and make our level designers iterate faster. As of October 2018, we actually played 25 million game rounds thanks to virtual players in Kubernetes Engine. Google Cloud Platform provides managed tool, and that enables us to remove the overhead on our team so we can spend all the time building new solutions and avoid all the technical issues that come with it. Next on our journey is building more tooling to democratize the use of machine learning in our data community, or for example the use of reinforcement learning to cope with the lack of data in our prototypes. Working with Google Cloud was a very good partnership. They've been very responsive and make itself available for us. So in the end, it helped us focus on creating new games, which is what we do best.
Hi, welcome to Google Cloud's digital conference, Let's Talk AI. I'm Levent Besic, a Group Product Manager here at Google Cloud AI.
And I'm Prerna Balara, a Cloud Customer Engineer.
Today we're going to talk to you about how we're making it easy for you to easily add a layer of intelligence to your applications and services using Cloud AI building blocks, pre-trained APIs, as well as AutoML. Now we have Googlers on standby to answer your questions live, so please click on the icon to your left and ask away, and don't hold back. As we can all agree by now, the capabilities of AI is not in question anymore. AI research has shown that it can and does power real-world applications with real business benefits. However, one thing that we hear quite often from our customers is that they're really struggling to integrate these capabilities into their end business applications. And when we double-click on why that's the case, one thing becomes very clear. There is a severe shortage of machine learning capabilities and skill sets and specialists out in the world right now. Take a look at this chart. We estimate that there are maybe thousands of deep learning researchers out there, maybe a million data scientists, but there is an order of magnitude more developers out there, 21 million that we estimate, and even more business analysts out there waiting to adopt AI into their business applications, but they don't know where to start, they don't know how to do it, and they don't have the data science skill sets. That's why our vision and our mission at Cloud here is to make AI easy, fast, and useful to all developers. We strongly believe that AI and machine learning is a fundamental technology that's going to revolutionize how we do things here in Cloud. And we think that it should eventually benefit all enterprises, regardless of their AI expertise. We realize customers are in different phases in their journey as they try to implement AI. And we like to meet our customers wherever they might be in that journey. To do that, we offer a comprehensive set of products across our Cloud AI portfolio, both for our data scientist friends and for developers, in primarily three categories. At the bottom layer here is our Cloud AI platform products. Our goal here is simple. We want to be the best platform and platform of choice for data scientists, where they can create models, iterate on them, deploy them, while being connected to one of the largest data scientist communities out there through Kaggle. At the middle layer here is what we call our Cloud AI building blocks, primarily geared towards our developer friends. Our goal here is to make it really easy and simple for developers to quickly and easily add a layer of intelligence into their applications and services without the need of understanding deep concepts of data science. And these APIs come primarily under sight, language, and conversation capabilities in a variety of feature sets. Finally, at the top layer, we have our solutions, which are primarily geared towards our partners, where we want to be their AI engine as they tackle key thorny workflow challenges that businesses faces, for instance, in customer service. As part of our building blocks, we offer two major flavors of them. We have our pre-trained models, where our goal is to offer off-the-shelf, easy-to-use APIs for your applications in a variety of use cases, which are ideal for common needs in your application, such as object classification or object recognition. On the other hand, we also realize that a lot of our customers need to create custom and high-accuracy models for their specific use cases, such as defect detection on a factory line. And for that, we offer our AutoML line of products, where you can leverage your own domain-specific data, as well as Google's own data sets, and then create highly specialized but very accurate models for your specific use cases. Since we talk about cloud custom models, let's dig into a little bit more and specifically talk about AutoML. So we know AI is hard. It takes a lot of time and effort to really create a successful model. It obviously has multiple steps, such as data pre-processing, model design, and then you have to do feature engineering, and then evaluate and deploy your models. This takes a lot of time and effort. And what we see in actual enterprise customers' experiences is that a lot of time, each of these steps take days, in some cases weeks, and it just takes over and over a lot of effort to get it right until you deploy a model. And that's why we designed Cloud AutoML. Simply put, AutoML abstracts the most complicated and complex aspects of machine learning model creation, from data pre-processing to model parameter tuning to evaluation. AutoML automates this process end-to-end and allows you to create highly accurate, powerful models for your custom needs easily and quickly, all through a simply UI-driven experience. So how does this work? Very simply, you have to upload a few training image sets for your specific custom model needs into AutoML UI. And what will AutoML do on the back end is create hundreds of different models using latest AI research and technologies, such as in transfer learning, create these models and iterate on them. We'll do a neural architectural search, pick the best one for your specific needs, and then we'll hook that up to a REST API that you can easily deploy and scale for your specific applications or services. So as we mentioned, all you have to do is upload your images to Cloud AutoML, and AutoML will do the rest to create this highly customized model for your specific business needs. Now we realize these custom models need to be really highly accurate for you to really make sure that you draw business value out of them. That's why we focus exclusively on AutoML to make sure it creates these high accuracy models for your specific needs. Take a look at this chart. In this chart, you see that we have some human data scientist generated models using image dataset, one of the most optimized datasets out there in Kaggle. And you'll see that our human generated models spread across different model sizes with different accuracies in blue dots. You can also see what AutoML has created using the same dataset in red dots. You'll notice two things here. At every given point, AutoML was able to beat the human generated models in terms of accuracy, hands down. And not only that, AutoML was also able to optimally trade off model size for accuracy. So for instance, the AutoML large model here is a significantly smaller model compared to the human-generated model at the large accuracy set. But also, if you look at AutoML medium, it's 5 times smaller in terms of model size, but only a few percentage points less accurate. This optimal trade-off for AutoML between model size and accuracy is key for your edge deployment scenarios. Now, unsurprisingly, the excitement around AutoML has been phenomenal by our customers. And what we've seen is a great many custom models created in a variety of verticals and horizontals. We can't wait to see what our customers will create further using AutoML in various other domains, such as in natural language, vision, and translation. Now, as I mentioned earlier, our goal is to enable developers to easily infuse AI into existing applications or build entirely new intelligent applications from scratch for a large spectrum of use cases. And we hence offer a comprehensive set of AI building blocks, primarily in 3 different buckets: sight, language, and conversation. Now let's go through each one of these one by one. And start with sight. Our first API is Cloud Vision API, which allows you to draw insights from your large image sets easily and quickly. You can do things like face detection, logo detection, as well as do object localization. We also recently announced handwriting OCR and product search capabilities as well. As you can see on your screen, Cloud Vision API supports a large feature set for whatever image API needs you might have for your products. Now, if you have a custom model need around your images, such as visual defect detection, for instance, on a factory line, we now offer AutoML Vision as well, which you can easily create a custom model with. All you have to do is upload and label your images on our AutoML UI. And what AutoML will do on the back end is create multiple models, pick the best one, and deploy that into a REST API that you can easily scale. For instance, if you are a retailer that is trying to catalog categorization application, you can easily upload your handbag, shoe, and hat images as your training set, and AutoML will do the rest and create you a model that can automate the categorization of your catalog quickly and simply. Now, let's do a quick demo to see how easy it is to create a vision custom model using AutoML Vision. Let's say that you're an application developer that needs to create a custom model to categorize types of cheeses that your customers might take pictures of. This is clear a custom model case, so let's figure out how you can quickly and easily do this in AutoML. First, you start on the AutoML Vision UI, and all you have to do first is to create and upload an image training data set here. You can upload your images and then label them here easily and quickly, or you can actually request a third-party labeling service to do this for you. So as you can see, you can very quickly create this labeled image training set. Here we have, in this specific case, various images of different types of cheese, such as brie, camembert, cheddar, goat, and Gouda. Once you have your images uploaded and labeled, next you come to your Train tab. Here you'll see your previously trained models, and you can also create a new model easily by clicking on this blue button. You'll notice that for the models that you created earlier, you have a quick overview of the precisions that you acquire, that you got from AutoML, as well as different metrics that you might be interested in. Now, in this case, instead of creating a new model, let's just quickly see an existing model and click on evaluation of it, which takes us to Evaluate tab. You'll notice that AutoML here used 741 images to train this model, and it received an average precision of 86% with 79% recall. Now, for most cases, this may be OK, but it may not be OK if you are looking for higher accuracy. In that case, let's figure out how we can actually increase our accuracy of this model. And a key feature here is what we call confusion matrix. If you scroll down, what you'll see is the areas where AutoML got confused the most between various training labels. So for instance, in this case, you can see that AutoML confused Parmesan for cheddar about 30% of the time. This is a great signal for you to upload a new and better image training sets around maybe more cheddar examples, right, as well as Parmesan examples, to really make sure that AutoML has enough data to go through and cycle through and get better accuracy on classifying those cheese types. Now, once you get the desired accuracy and precision of your model, all you have to do is then go to Predict tab. And here, you can actually upload various new images where you can test the accuracy of your model. Again, you can upload new images that you might take with your camera just right off the phone and see how the model does. And again, once you're happy with that, all you have to do is copy and paste this code snippet and get it into your code, and you're ready to go and scale. That's how easy it is to create a custom model using AutoML image. A great customer case study for AutoML Vision and its power comes from Bloom, which is a furniture hardware manufacturer based out of Europe. Now, Bloom offers hundreds of different types of products that look very similar to each other. And then they realized that their customers were having difficult time differentiating between these different types of products that look very similar. So for instance, take a look at these two hinges that we got off their website. You can see that these hinges look very similar, but they're very different types of product, again, with different price points and different feature sets. Now, Bloom realized that they could use AI and machine learning to create a custom classifier, but they had no in-house ML expertise to do so. And that's why they turned to AutoML. In just 5 weeks, Bloom was able to create this custom classifier with AutoML that reached 91% peak product recognition accuracy. This customer case study just speaks to the power of AutoML. You do not need a data science expertise in your enterprise or in organization anymore. All you have to do is you use AutoML and harness the power of machine learning and create these custom models for your specific business use case.
Thank you for that, Leven. As you know, Leven spoke a little bit about the first building block of AI, which is sight. I'm going to go a little bit into language and conversation. So natural language API is pre-trained on Google Cloud data. So it helps you extract entities, detect sentiment, and analyze syntax, as well as classify content on your text based on Google data. It's pre-trained, and the labels have been set at Google as well. But now, what if I want to classify based on my own content? In that case, look at AutoML natural language. It allows you to classify the text and label it based on your specific use case or on your specific domain as well. Similar to AutoML, which Leven just walked you through, AutoML natural language is just as easy. It allows you, all you have to do is upload a labeled text file and click on a button, and it'll train the model for you. What it does is it does something called supervised learning in the back end, as well as feature engineering and hyperparameter tuning as well. But what I've realized so far is, while I can talk about features, I think it's best to just walk through a demo to better explain AutoML natural language and walk you through the features. So I'm going to jump into a quick demo. What we've done here is we have uploaded we've uploaded the data set from donorschoose.org, which is a nonprofit that receives hundreds and thousands of proposals each year for classrooms in need of funding. Volunteers have come in and labeled these texts into different categories, such as art supplies, food, clothing, sports exercise equipment, so on and so forth. This data set is actually published in Kaggle, and it's open source. But what I wanted to point out over here is that AutoML natural language allows you to have multi-label classification. What that means is, theoretically, one of these texts can be classified as art supplies and sports exercise equipment, or any other bucket as well, depending on the request that you have put in. Once you've uploaded the text on this UI, what you need to do, like you did in Vision, is move to the Train tab. This is exactly like the AutoML Vision UI, if you've noticed. All you need to do is to click on a Train New Model, which allows you to build a new model for the data set that you've just uploaded. One feature that I actually like about this is that once you click on Train New Model, it actually gives you an email notification saying, hey, your model has been trained. So while your model is training, if it's taking a few minutes or a few hours, depending on your data set, you can go grab lunch or coffee, which works great for me. Let's look at the full evaluation. Notice that the label, the UI, and the way it's structured is very similar to AutoML Vision. So that basically means that you have 0 to very little learning curve. You can see that this has labeled the data, and it has given me a precision and recall as well. We have a 91.9% precision and an 89.8% recall. And I can drill into specific labels as well to see the accuracy and to better tune my model as well. Additionally, you can also, when you go lower into this page, you can see the true positives and false negative classifications, as well as the false positive classifications, thereby allowing you to upload accurate and better data. But Prerna, we have finished training, we have finished uploading. How do I serve this model? Exactly like AutoML. You can see that there is a box over here, similar to you saw in the Vision flavor, where you could upload your images. Here, because this is text, you can type in text as well. I'm just going to type in that says something simple that says, my students need basketballs, just because. And you can see that it has given it an accuracy of 0.99 as sports exercise equipment classification, and it has given it nearly 0 for the other types of classification, thereby showing you the multi-label classification feature as well. If you don't want to have a UI like this serving your customers or your end users, you can also use the REST API code or the Python code that you can see on this page, thereby allowing you to scale and serve your model. And that's it for the AutoML natural language demo. Let's move ahead to look at a quick use case as well. Hearst is a leading newspaper company based in New York City, and they've been on Google Cloud for some time now. They're very excited about AutoML natural language, and they're using the natural language to classify their articles and content using custom models that meet their specific needs to reach higher accuracy than they could achieve using their custom models, and with lesser time. Let's switch gears towards a translation API. The Translation API offers you the same technology that you see with Google Translate. It understands and categorizes over 100 different languages. It has the features to do language detection. It has real simple, really easy integration using the REST API and gRPC. And it's highly scalable because of this. Similar to the Natural Language API, this has been pre-trained. So if you want to customize this to your specific use case or to target your specific jargon, you may want to use the AutoML Translate. Let's look at a use case for Translate. Airbnb, like most of you know, facilitates global travel. 50% of Airbnb trips are across a country border, and what Airbnb realized was that 60% of their bookings connect guests and hosts who use app in a different language from each other. This means that while Airbnb connects diverse groups and guests and hosts from all over the world, they aren't always able to communicate with each other. Google Translate helps us bridge that gap. When we introduced Google Translate as a functionality on listing descriptions, they saw a statistically higher improvement in their guest likelihood to book. And this is a use case that you can use for your applications as well. Since the world is getting global, language should no longer be a barrier, right? But if the pre-trained models and the labels aren't good enough for you and you want to customize it to your own jargon and your use case, then AutoML Translate is the application for you. It allows you to translate custom models and use language pairs for your own custom model as well. Similar to natural language, all we ask of you is to provide a training label dataset, and using supervised learning and hyperparameter tuning, AutoML Translate will build a model for you using your training data. And like you saw in vision and in natural language, it allows you to evaluate and serve these models very easily, thereby allowing you to scale and reducing your machine learning turnaround time. Nikkei Group is a leading media organization. It's a trusted financial news source. And what they realized was when they were translating their articles from Japanese to any other language using the straight out of the box pre-trained translation API, the accuracy wasn't as good as they expected. What they decided to do then was to use AutoML translation. What they realized after using AutoML translation was that they not only hit higher accuracy, but they also had faster turnaround time, thereby becoming one of our happy customers of AutoML translation. We've spoken about site, we've spoken about language. Let's look at the last leg of our building blocks, which is conversation, which consists of Dialogflow and text-to-speech and speech-to-text API. The text-to-speech API team produces synthesized speech across multiple languages that are used in a range of Google products, such as Google Assistant, Maps, Translate, amongst others. This text-to-speech API gives you access to the same service that Assistant and Maps use today. It allows you to use WaveNet technology. It's the only cloud service that allows you to use WaveNet technology, as well as it's very easily scalable with REST or gRPC APIs. Let's look at the next one, using speech to text. Being able to translate speech to text is key for applications to understand humans. Speech to text offers a collection of pre-built models tailored for your use case. It currently recognizes 120 languages and variants. It automatically identifies speaking language, as well as returns transcription in real time as well. Like the text-to-speech API, this is also very easy to use. It's almost plug and play with the REST APIs and the gRPC calls, and thereby allowing you to scale. Let's look at the last conversation product, which is Dialogflow. Dialogflow is a conversational interface, which means that it can take inputs from users through choice of channel, like voice, text, social media, all very easily through the click of a button, and process it to fulfill the intent of the user. An example of an intent can be buying tickets or delivering a package. It is powered by machine learning to recognize the intent and context of what a user says, so you can create a natural and rich interaction, thereby building and creating a positive user experience and affecting your business in a positive way. It can easily be integrated with a number of social media platforms as well, providing a more holistic and positive customer experience. Let's look at a use case for Dialogflow. Ubisoft is a video game publisher that has been using Dialogflow as a way to provide personalized information and tips to its gamers. What they have realized since using Dialogflow is that in the first 3 months, 88% of their requests were already handled by the bot. thereby improving efficiency and reducing the resource use. So as you know, at Google Cloud, our mission is to democratize artificial intelligence. And to that end, we've been building tools that help you, developers, data scientists, achieve this goal as well. We spoke to you about the cloud AI building blocks. We spoke about sight, language, and conversation. You saw that some of our models or some of our applications don't even require you to write a single line of code. And we hope that these applications or these building blocks can help you achieve your use case. Thank you for joining us today. Please stay tuned for the next session, and we hope you enjoy the conference.
Welcome back from AI Made Easy, Pre-trained Models and Cloud AutoML. You learned that whether you're new to ML or you are already an expert, GCP has a variety of tools to help you. Pre-trained models and Cloud AutoML really get to the heart of Google's expertise and mission. The company has spent years organizing the world's information and making it accessible and unleashes the learnings from processing so much content to others. In other words, pre-trained models make everyone else's model smarter and faster. It's similar with Cloud AutoML. We get that not all organizations can afford big data science teams. We take our best engineering talent and make machine learning more accessible for all companies. Starting with our pre-trained models or ML APIs, this API doesn't require any training. Ready to plug into your code and perfect for generic use cases such as image classification for animals. They then dived into how to customize pre-trained model with Cloud AutoML. Using AutoML technology, you can use your domain-specific data in its dataset. It uses your dataset and builds on top of our dataset for training using transfer learning, perfect for specialized use cases such as the defect detection on the factory floor. AutoML abstracts most complex aspects of machine learning, from data processing, model design, all the way to deployment and retraining of your models. We wanted developers to have user-friendly experience building models without compromising on quality. Our vision at Google Cloud is to make AI easy, fast, and useful for all developers. We believe AI is a fundamental cloud technology that should eventually benefit all enterprises regardless of AI expertise. In order to meet our customers wherever they are in their AI journey, we offer a comprehensive set of product portfolios for both data scientists and developers. Our products come in primarily in 3 buckets. At the platform layer, our core audience is data scientists. At the middle layer, our core audience is developers, and our goal is to make it super easy and fast to implement ML in their applications and services. Last but not least, we offer an array of solutions to our partners where our goal is to be their AI engine as they tackle the thorny workflow and business problems that our enterprise customers have, such as in customer service. Lastly, they dove into Dialogflow, which is a conversational interface, which means that it can take inputs from users through their choice of channel, like voice, text, or social media, and process it to fulfill intent of the user. An example of an intent can be buying a ticket or delivering a package. Now, while our ML tools empower you to perform ML regardless of experience level, but by abstracting a lot of the low-level infrastructure and the modeling needed, what if you do want to get your hands on and harness the power of ML-optimized processors? If you haven't heard of TPUs or tensor processing units, our next session, TPUs for developers, getting started on Google Cloud TPUs, will dive into that. You will later see a demo on it, and we're very excited to show you that our amazing chip that our company has deeply invested into make machine learning super fast. Cloud TPU is a TPU board with 4 dual-core TPU chips connected to a host virtual machine. The TPUs will typically be running training on your model, while the VM is working to get the data into TPU as fast as possible. They'll also dive into different scenarios in which utilizing TPUs can deliver maximum speed for certain workloads. and when it not might make sense as well. In addition, you'll learn about its hardware and software intricacies and architecture. Another cool thing you'll hear about are our goals to integrate estimators in TensorFlow to support TPUs and integration for Keras as well. And of course, if you want to get your hands on TPU and start training, please stay tuned.